In this lecture, I want to talk about some further topics that you can study. We're basically winding up the class, we're wrapping it up. And so we didn't get to cover everything. Obviously, it's a beginner class. So there are a lot of advanced topics that you can further study for C to really become awesome at C programming. And I just wanted to mention a couple of those. So first off, we didn't get into type defs. I would have liked to have talked about that, but it is more of an advanced concept. We talked about enums, and enum is a way of creating your own type. But specifically in C, there's a keyword called type def, and you can create your own data types. This is very useful, more of an advanced concept. You could definitely learn more about that. There's a lot more information on the preprocessor that you can learn about, specifically string concatenation. The preprocessor, remember, that runs before the compiler. We learned about the define statement. We learned about a couple other things here and there, but the preprocessor can be a whole nother section with a lot of more information on it. You can use it basically to optimize a lot of your code so that you can run it beforehand. You can do inline functions that run in the preprocessor, all a bunch of nice concepts. There's a lot more on void stars. Void stars, remember, allow a lot of flexibility. In particular, the malloc function returns a void star. We could create functions, take void pointers and pass the void pointers around to make them more flexible. There's a lot more we can study on that. Static libraries and shared objects. We didn't talk about this concept of a library. We use libraries when we link. Specifically, a lot of the libraries are defined in the C standard libraries. But you can create your own libraries. We created programs. Programs are processes that run in memory. But libraries are actually other code that you can reuse in other programs. So example, the C standard library. If you've programmed in other languages, usually they're APIs that come with the language. There's two types of libraries that you can create. You can create a static library where you compile all of that code when you link. And then you can also create a shared object where during the execution of the program, you're going to look up functions and invoke them. So static libraries are usually end in a .a, and they get compiled in at static time, or they get compiled in when you compile the program. Shared objects are .so files, or they're also, you can kind of think of them as DLLs if you've ever heard of dynamically linked libraries in Visual C++. But the shared objects are not compile time. Again, it's a way to reuse code. We could study these concepts, and I could show you how to build static libraries as well as shared objects. Macros. We didn't get the chance to talk about a macro. This is an advanced topic. This gets run by the preprocessor to mainly do substitution, string substitution. Some of the functions that we studied are actually written as macros, like the assert macro. Macros can be much more explored in much more detail. Unions will usually go along with structs. It's a way to have multiple different types of data returned, or different types of member elements inside of a struct that represent the same thing. So you could have a structure that has one member, but that member can be an int or a float, and you would use union to do that. Other topics, function pointers. We talked about character pointers mainly, and even integer pointers and double pointers, but you can actually have pointers that point to various functions. So as your program is running, you can execute one function, and then the next time it runs, it could execute a different function based on user input or something like that. Function pointers are a whole other topic. Advanced pointers, there's a lot more to pointers than what we've discussed. We discussed the basics of pointers, but we could talk about pointers in much more detail. There are actual pointers to pointers, so there's double pointers, and that is a more advanced topic. Variable arguments to functions, these are referred to as variadic functions. We use the printf function that has a variable number of arguments, but we didn't define any functions that we had variable number of arguments. We could explore that concept, very useful. Dynamic linking. This is when you open up a library at runtime and you don't actually, it's a little different than a shared object. You can open up libraries at runtime and it increases performance and it makes your executable programs smaller. So DLM open, there's an actual library call to do this. Signals, forking, inter-process communication. This can all be explored. Inter-process communication is when you have two programs and they want to communicate. There's a different ways that they can communicate. They can communicate via files. They can communicate via something called a socket. They can communicate by using piping. There's different techniques out there, but it's when two processes want to talk to each other. Forking is where you can create another process. There's libraries to create other processes in your code. If you were to create another process in your code, it would have its own address memory space, and it can make your program a little bit more efficient. And then signals we didn't get into a lot of, but signals are used for debugging and to generating different messages to different programs. Threading and concurrency, another advanced topic that you want to study. This allows multiple execution points inside your program. It allows you to run code almost at the same time. So it's an efficiency type thing. If you have a long running task that you need to do in your program, such as monitoring data or waiting for data, or maybe your task is reading a huge file, you can create another thread to do that and then still execute other parts of your program in conjunction at the same time. Sockets are used for networking. Sockets would be used if you wanted to connect to another computer and get data from that other computer. Networking is very, very big because we have the internet and everything else. So you can learn all about sockets in C as well. There's two functions called set jump and long jump. That's for restoring state. We could study those in good detail. More on memory management and fragmentation. This isn't just about malloc, but this is how you can manage your memory and put it on the heap or the stack. You can make sure that your program is a little more efficient so you don't have as much fragmentation. Fragmentation is where you have memory in different locations and it's not sequential, so it may be harder to take more time to look up that memory. You can reduce fragmentation. We can work on making the programs more portable. In general, C programs are pretty portable, but there are more techniques that you can utilize to make sure that when you write your program once, it runs on many different operating systems and you don't have to rewrite it. We could essentially use some of the POSIX standards that are available in C. We can make sure that depending on what different version of the C standard, that they work in multiple standards by using certain conventions. We could also write programs that directly interface with the kernel. Remember, the kernel is the brains of the operating system. The kernel does contains all the drivers. It contains all sorts of calls to lower level memory functions. It does a lot of different information. So the kernel has specific functionality where you can interface with it in your C program. This would be low level embedded stuff. So we could use calls like IO controls. We could create drivers to talk with hardware directly. There's a lot more on the compiler and different flags that you can pass to the compiler or the linker, which again makes your program more efficient. We didn't get a chance to talk about a lot of different various flags. We talked about the dash wall and some other basic ones, but nothing more advanced. We talked about the debugger and how to debug applications. The debugger in code blocks was through the graphical user interface. But the real advantage of a debugger is under the hood it uses GDB. GDB is the GNU debugger. And we only talked about breakpoints and using it through the graphical user interface, but you can actually do a ton more with GDB. We could go through the GDB debugger from the console, issue different commands, do a lot more with the core file, understanding how to read the core file using GDB. A lot of nice advanced topics there. Profiling and tracing tools. We didn't get to talk about some static analyzers, some tools that can analyze your code before you run your program to see if there's any dead code or if there's any bad programming practices. And then tracing tools as well, strace, dtrace, gprofile. Those are all important tools you can use with C to help you debug and help you measure efficiency or how much memory you're using or the performance of your program. There's other additional memory debugging tools such as valgrind. This helps when you have like race conditions or you have memory corruption problems. A lot of times when you're managing your memory and you have buffer overflows or you have memory leaks, it's very, very hard to find those. So there's tools out there that can help you find those, such as valgrind.